Hi, welcome to my Mathcast. The intended audience is grade 6. The content or learning objective is students use nets to determine the surface area of three-dimensional figures, created by Countryman. Our vocab is surface area. Surface area is the sum of the areas of the faces of a three-dimensional object. So you're using area to add up each side of the net shape to get the surface area. So in this example, we have one box and it gives you the net shape and all laid out so that it's this shape laid out, and together it's 6 square units, and we can count that by 1, 2, 3, 4, 5, 6 square units gives you the area. And in this one, we have the net shape here as well of this cube, and together it's 24 square units. Our first example is use the net to calculate the surface area of the figure. All measurements are in centimeters, so we should highlight that this is in centimeters. And next, we can color it in. We see that we have 1, 2 of the same shape, and then 1, 2, 3, 4 of a second shape. So now that we have that, we can calculate the area, or the surface area, by saying that there first are 2 blue squares and their dimensions are 2 by 2. And in this one, they're also 2 by 2. So 2 times the surface area equals, we know that that's 2 times base times height. And then so 2 times 2 times 2. So that's 2 times 4. So that means that for the blue squares, it is 8 squared centimeters. And now that we see that. And then in our second shape, we have 4 rectangles. And their dimensions are 2 by 1. And they are also that for the vertical rectangles. So, and we have 4 of them. So we would do 4 times the surface area equals 4 times base times height. So that's 4 times the base, 2 times the height, 1. So that's 4 times 2, which equals, again, 8 square centimeters. And with that, we can add them up, because for the total surface area, that is shape 1, so shape 2 plus shape 1, or shape 1 plus shape 2. So that would be 8 square centimeters plus 8 square centimeters. And altogether, that would be 16 square centimeters for the total surface area of this net shape. Our next example is to name the solid the net would create and then write an expression for the surface area. Use the expression to determine the surface area. Assume that each box on the grid paper represents a 1 centimeter by 1 centimeter square. Explain how the expression represents the figure. So first we have 1 square base right here, and then 4 triangle faces. Because of this square base with 4 triangle base faces, that means we have a square pyramid. This means the total surface area equals the area of the 4 congruent triangle faces plus the area of the 1 square base. So we would do 1 times base times height for the square plus 4 times 1/2 base times height for the triangles. Next, we can solve for the square. So first we see that it is 1, 2, 3, 4 by 1, 2, 3, 4 centimeters. So 1 times the surface area equals 1 times base times height. So 1 times 4 times 4, which equals 1 times 16. So that is 16 square centimeters for the square base. Next, we can calculate for the triangles. We see that they have a height, 1, 2, 3, of 3 centimeters. So we would do 4 times the surface area, because there's 4 triangles, equals 4 times 1/2 base times height. So 4 times 1/2 with a base of 4 still, times 3 for the height. So it's 4 times 1/2 times 12. So now we have 4 times 1/2 of 12 is 6. So 4 times 6 is 24 square centimeters. With this, we now need to add for the total surface area. And as we said up here, we need 1 times the base times height, which we did right here. So that's 16 square centimeters, plus the 4 times the 1/2 base times height for our triangles, which together would be 24 square centimeters. When you add 16 plus 24, you get 40 square centimeters. So the total surface area of the square pyramid is 40 square centimeters. Thank you for watching my Mathcast. The resources I used were the Math Vocab app and the Engage New York website.